So sometimes we want to find out if a given reaction mixture, a bunch of chemicals in a beaker or whatnot, are going to react in a specific reaction in the forward direction or the reverse direction. So for instance, in this case, we happen to have some solid sodium chloride and some sodium ions and some chloride ions. And obviously, because these are not the same concentration, we must have some other ions in there too. So we have a bunch of different salts that we've thrown into this beaker and added water. And initially, we have this concentration of sodium ion and this of chloride, and then some solid sodium chloride. And the question is, do we go in the forward direction to make more dissolved sodium chloride, or do we go in the backward direction to precipitate the solid sodium chloride? Okay, and we're given some information. We're given that delta G standard for this reaction is -8 kilojoules per mole, and we're given what the temperature is. So there's two methods to do this, one involving finding out what delta G is, and then this other method, which I'm going to show you now, which is comparing K and Q. So in other words, using the equilibrium constant. Okay, so what we're going to do is calculate K for this first. So sometimes you'll be given an equilibrium constant, but in this case, let's calculate our value of K equilibrium from delta G standard. So we're going to take our delta G standard and use it to calculate K equilibrium. And we can do that because delta G standard is equal to negative RT log of K equilibrium. Okay, so let's use that equation to do that calculation. All right, so we were given delta G standard and the temperature. So let's solve this for K. So we get delta G standard divided by negative RT is equal to the log of K. So K equilibrium, let's take the exponential of both sides, is going to be negative delta G standard over RT. So we plug in our numbers, and we had a negative of a negative 8 kilojoules. So we've got 8,000 joules per mole divided by 8.314 joules per mole per Kelvin, and the temperature, which we had to convert to Kelvin, 298 kelvins. Okay, so you can see how everything cancels, which is good because you can't have units inside an exponential, so moles cancel moles, kelvins cancel kelvins, joules cancel joules. Okay, very good. So when we punch that in, we get that this is equal to 25. So that's the value of our equilibrium constant at 25 degrees. Now let's compare it to Q. So what's Q? So Q is our reaction quotient, and we know that is the concentration of products over reactants. So we've got sodium. Let's go back and look at our reaction for a second. So if we look at our reaction of interest, we can see that our products are sodium and chloride ions. We put those on top. We don't have any exponents to worry about because there's no coefficients here, just ones. And then we look at our reactant is a pure solid. So remember, we can plug that in as just an activity of 1. Sometimes we just leave that out because obviously it doesn't affect the numerical value of Q. Okay, so let's plug in our numbers. So our original concentration of sodium we said was 3 molar. Our chloride was 10 molar. So we can see Q is equal to 30. So Q is greater than K. Let's see what that means in terms of reaction direction. To do so, it's useful to have a G versus Q graph. You may have seen your professor draw one of these in class, or maybe you've seen one in your textbook. So for this particular reaction, the Gibbs energy of the pure ions is going to be lower than the Gibbs energy of the pure solid. So we get a curve that looks like this. So equilibrium lies to the right. The system's going to react from either point until it gets to the equilibrium point, the point where its Gibbs energy is at a minimum. So we know that the more we increase entropy, the more we decrease our Gibbs function. So when you have this middle region here where you have a mixture, we have a decrease in Gibbs energy. So anyway, our equilibrium constant is here. Let's label that as KEQ. So we just said that Q in this case was greater than K. So where are we on the curve? We must be on the right-hand side. We're over here. Now, if you're over here, where the value of Q, that's the x-axis, is greater than K, you can see to go downhill in energy, you actually react backwards. In other words, you're going to be precipitating sodium chloride. So the reaction is actually going to go to the left. Okay? So that's a general principle. Whenever Q is greater than K, your reaction is going to react backwards and produce reactants instead of producing products. Okay, so in this case, what we'd see is the formation of more solid because their concentration of the individual ions is too high.